dear students of class 9. We have discussed modern periodic table in our previous video. Today we will be discussing about general trends in modern periodic table. So, in periodic table, you know, as you go from top to bottom, you have how many rows? You have 7 rows. How many rows? 7 rows. And these 7 rows are periods, and you have 18 vertical columns. How many of them? 18 vertical columns. Which are known as what? Rows. So this you should remember in it. Okay? So today we will be discussing about the properties about elements. How does it vary as you go from top to bottom or from left to right in the periodic table? So as you come down in the periodic table from the top, as you move from top to bottom in the periodic table, you have to remember that as you move from, suppose you are in first period, then you come to second period, then third, then fourth, then fifth, and it goes on like that. Okay? So first period will be having only one cell. That means one orbit. In the second period, 2 cells. Likewise, in the third, 3 cells. In the fourth, you have 4 cells, and in the fifth period, you have 5 cells. And so it is very easy to remember. And this is very important. Okay? The number of cells will be equal to the period in which that particular element lies. So let's take an example of say lithium. First, let's take hydrogen. So hydrogen, its atomic number is 1. So its electronic configuration is just 1. In the second period, just below hydrogen, you have lithium. Lithium has atomic number 3. So its electronic configuration is 2. 1. So you can see that here you have 2 cells. In the first cell you have 2 electrons, and in the second cell you have what? So this is the structure of lithium. In the first cell you have 2 electrons, and in the second cell you have 1 electron. Okay? So 2, 1. This is the structure of lithium. Hydrogen has only 1 electron. Now below this you have sodium. Sodium's atomic number is 11. So 2, 8 and 1 is the electronic configuration. In the first cell it has 2 electrons, in the second cell it has 8 electrons, and in the third cell it has 1 electron. So likewise, you have to remember what? What should you be remembering? You should be remembering the number of cells of an element is equal to the period in which it lies, and this is very important. Now let's talk about valency. Valency, hydrogen, lithium, sodium, you have 2, 8 and 1. So you can see in this case all of them are having 1 electron in the valence cell. How many? Valence cell is the outermost cell. Okay? So all of them are having what? Valency 1. That means all these elements you can see in the periodic table, they lie in the first group, first column, first row, and since they lie in the first group, they will be having the same valency. I mean to say the number of valence electrons. Okay, valency differs. The same number of valence electron. So if it lies in group 1, that means that all of them will be having valence equal to 1. Now if it lies in group 2, it will be having valence equal to 2, or number of valence electrons will be equal to 2. Now since we are discussing about valency, let's discuss this in little more detail so that you won't be confused. Now let's take period 2 element. Period 2 element. In period 2, in first period, you have hydrogen and helium. In the second period, that means the second row. If you are confused, please refer to your book. In second period, second row, what you have? You have lithium, hydrogen, lithium, beryllium, boron, then comes carbon, then comes nitrogen, then comes oxygen, then comes fluorine, and you have neon as well. So, we are discussing about, please listen to it very carefully, okay? Valency. Now, here lithium's valency is 2, 1. So 1 electron has in the valency, therefore its valency is 1. It keeps on increasing with respect to hydrogen we are discussing. 2, 3, 4. See here, the number of valence electrons here, in this case, in lithium, it is 1. Here, it is 2. Here, boron, electric configuration is 2, 3, 4 carbon, 2, 4, then 4 nitrogen, it is 2, 5. This 4 oxygen, 2, 6. For fluorine, it is 2, 7. And for neon, it is 2, 8. So, here, up to carbon, the valency will be equal to the number of electrons in the valency. So, in the valency, you have 1 electron. For lithium, valency is 1. Valency is 1. We are discussing about valency. Please don't forget. In case of beryllium, you have 2 valence electrons. Valency is 2. In case of boron, you have 3. Boron has 3 electrons in the valency. Valence is 3. For carbon, it has 4 electrons in the valency. Its valency is 4. Now, as you go higher now, nitrogen has 5 electrons in the valency. Yes or no? How many? 5 electrons in the valency. To have noble gas configuration, whenever an element has 8 electrons in the valency, you must have heard about octet rule or noble gas configuration, or you can see from here itself. Neon is a noble gas configuration. It has 8 electrons in the valency and it's very stable. All other elements, they also want to be very stable, and for that they need to have 8 electrons in the valency. Okay. Now, whenever you come to nitrogen, it has 5 electrons in the valency. How many more electrons are needed to be octet? That means 8 electrons in the valency. 5 plus 3. Whenever it gains 3 electrons, then 5 plus 3 will be equal to 8 in the valency, and before that it has 2 electrons. So to be 8 in the valency, how many more electrons it requires? It requires 3 electrons. Therefore, its valency is 3. Likewise, here it requires 2. This is fluorine. For fluorine, it has 7 electrons. It requires only 1. Therefore, its valence is 1. And for neon, it is already 8. Therefore, its valence is 0. So this is how you need to predict the valency. And once you know their atomic number and you will be able to write its electronic configuration, you will be able to know its valence. It's very simple. And for this, you must at least remember the atomic numbers up to calcium. Please don't forget that. Do it. Now let's discuss about reactivity of alkali metals. Now, to discuss reactivity of alkali metals and halogens, we need to discuss about the size of the atom. Now let's first discuss about the size. How does it vary? We are going to discuss about atomic size. Now, as you move from left, your left hand side of the periodic table, to right hand side of the periodic table, size will decrease. Size will decrease. Why will it decrease? Because the atomic number increases. Okay? As the atomic number increases, the number of electrons also increases, and the number of protons in the nucleus also increases. So protons are positively charged, electrons are negatively charged. More positive charge, more negative charge, more attraction. If the attraction is more, what will happen to the size? The size will decrease. Please remember. Okay? size will decrease because of increased nuclear force of attraction. And this is where, whenever you are moving from right hand side, left hand side of the periodic table to the right hand side of the periodic table, that means across the period. This is, you are moving across the period. What will happen? The size will decrease because of the increased nuclear force of attraction. Okay? Now let's discuss what will happen to the size as we move from top to bottom in the periodic table. Now this you should already be knowing from today's discussion. So we discussed what? If you have an element in the first period, then how many cells it has? 1 cell. Second period, 2 cells. Third period, 3 cells. Now this number of cells are directly related to what? The size of the atom. So like in case of lithium, we had, in case of hydrogen, let's take hydrogen first. Hydrogen, what you had? Hydrogen, you had only 1 cell. So the size of hydrogen was this, where it had only 1 cell. Then you have lithium. Lithium has 2 cells. Therefore, the size of lithium is greater than that of what? Greater than that of hydrogen. And here, now in case of below this, what was it? Sodium was it? Sodium was having 2, 8 and 1 electron configuration. How many cells are present? 1, 2, 3. So sodium, you have first cell in which you have 2 electrons. Then you have second cell in which you have 8 electrons. 3, 4, 5, 6, 7, 8. Then in the valence cell, that is the outermost cell, you have 1 electron. So you can easily make it out from the number of cells. Hydrogen lying in the first period, 1 cell, small in size. Lithium lying in the second period, 2 cells, bigger in size compared to hydrogen because it has 2 cells. Sodium, it has this electronic configuration as 2, 8, 1. That means it has 3 cells, and it lies in the third period. So you saw from this example, as you move from top to bottom in the periodic table, the number of cells keeps on increasing. As a result, what will happen? The size keeps on increasing. So this was with regard to the size of the elements. How does it vary from left to right in the periodic table and from top to bottom in the periodic table? Now let's discuss about metallic character. Metallic character. See, this particular topic, periodic table, is also there in your ICSE class 10 first chapter. And all these things, if you don't have proper understanding of this particular trend, then you'll not be at a good state in class 10. Therefore, please listen to it very carefully. So, metallic character, what does it mean? Metallic character means the ability of an element to lose its electron. If it can lose easily, then it will be more metallic, and if it is finding it very difficult to lose, then that will be less metallic. So I'm telling you what metallic character is the how easily an element loses its valence electron. That is known as what? Metallic character. So let's discuss how does it vary. Now from left to right, in the periodic table, what happened? I told you the size keeps on decreasing because of what? Nuclear force of attraction. Now if the nuclear force of attraction is more, then this valence electron is held tightly by the nucleus. If it is held tightly, means what? It is finding difficulty in losing. Therefore, what happens? So from left to right, metallic character increases. Why? There is increase in nuclear force of attraction. Okay? So what happens when you move from top to bottom in the periodic table? Now as you move from top to bottom in the periodic table, you saw what? The atomic size keeps on increasing. Now whenever the atomic size keeps on increasing, what happens is the electrons which are present in the valence cell will be less tightly held by the nucleus. For example, say this is hydrogen. Hydrogen has only one cell with one electron. Lithium has two cells with three electrons. Now here itself you can see that this is the first period element which is lying in the first period. This is the element lying in the second period. So you saw as you go from top to bottom in the periodic table, the number of cells increases and the size increases. As a result, the positive charge present over here are less effective in holding the electrons which are present in the valence. The distance is more, therefore attraction is less, and hence the electrons can easily be lost. So if the electron can easily be lost, then it becomes more metallic. From top to bottom, therefore we come to the conclusion that metallic character increases. Now same goes, say metallic character and reactivity of metal. They follow the same trend. Now from top to bottom, the reactivity of the metal, the reactivity will increase from top to bottom, and the reactivity of metals from left to right, it decreases. And let's discuss about one more point here, that is oxides. Oxides of metal. We are going to discuss about oxides of metals. Now on the extreme left of periodic table, the oxides of metal like lithium oxide, they are highly basic. They are highly basic in nature. As you move towards the left hand side in the periodic table, they become less basic, and finally they become acidic, and the oxides which are present at the extreme left are acidic oxides. Okay, acidic oxides, please don't forget. So what is happening with the oxides of metal? If they lie on the extreme left, they are highly basic, then it keeps on decreasing, as you move towards the right hand side of the periodic table. In between, they become amphoteric. Amphoteric means now they will be showing both acidic property as well as basic property. That means amphoteric nature, that means both. Sometimes they act as acidic nature, both basic as well as acidic. And finally they become acidic, and after becoming, as you move to the extreme right, they become highly acidic oxides. So this is a trend how this oxides, the nature of the oxide, it varies in the periodic table from left to right. So with this we come to end of today's class. We'll be seeing you in the next video. Today's class is very important from the perspective that next year you will be going to class 10, and in the first chapter you have to come across these periodic trends. Hope you will revise it properly. Thank you. Take care.